All right, you guys. So, hopefully this is going to work out. I'm kind of trying it out. Here we go. It occurred to me that you might benefit a lot from seeing another example of identifying forces, interacting forces, or force pairs when different objects are interacting with each other. So, there's a diagram in your book. This is on page 103, and it's figure 4-12. And that's what I'm going to be discussing with you. Well, they got a picture of Earth, and this is certainly not drawn to scale. Um, this makes no sense drawn to, if you think about the scale of things. But what you've got is a ball on a table on Earth. Okay, so they do this just to give you an idea of some objects that are interacting. And what we want to do is we want to try to figure out, well, okay, what are the forces involved? And so let's look at that. We have to take these objects one at a time. So we have a ball. What are the forces acting on the ball? Well, there's a field force, of course. You know, you guys are used to seeing that. That's an E. There's weight. Now, what is weight, though? Weight is a force caused by Earth acting on the ball. So that's the notation I'm going to use. A force caused by something acting on something else. All right. And so what else is happening? Well, the table is pushing up on the ball. The table is preventing us. So we have the table creating you would call that a normal force, but this is really the force of the table on the ball. These two do not, sorry about that shake, these two do not make a force pair, or they're not twins of each other, because they both act on the ball. Okay, well, we're going to look at some other objects, the table, and then Earth as well, and we're going to see where we can identify some pairs or twins of forces. Now I'm going to look at the table. So at the table, yeah, obviously there's weight, and that is the force of Earth on the table. And now the table, though, is in contact with two things. It's in contact with the ball, and it's in contact with Earth. So the ball is interacting with the table. This is going to be force of the ball on table. And then Earth itself is interacting with the table. We have a force of Earth. This is going to look weird. Earth on table. It looks like we have that twice. Well, here's the deal. This force of Earth on table, where there's contact, this really is a normal force. And this weight really is force due to gravity. You can see that. So I want to keep that straight in my head. All right, maybe I can write this down on paper. This weight is a downward force, right? You'd agree with that. The ball, since the ball is above the table, the ball must be pushing down on the table. That's a downward force. And Earth here, in contact with the legs of the table, must be pushing up on the table. There's an upward force. Okay. Well, how about the directions of these guys? Well, the weight's a downward force there, and the table pushing up on the ball. Okay. And there's nothing else touching the table, so no other forces to worry about there. What about Earth? Now, we don't often have to deal with Earth, but it's interesting to look at it. The forces do exist. Well, okay. What is in contact? Let's start with the contact force here. What's in contact with Earth? Just the table. So, table is touching Earth. Therefore, it's going to be a normal force. And this is going to be force of table on Earth. Okay. You'll see right away that this way of writing it down, force of something on something else, is real handy. Because what I have going on is I see the twin of this already somewhere else. Since this is a normal force, it's a contact force. I'm going to look at table on Earth, and I'm going to reverse those and say, where's the contact force of Earth on the table? contact force of Earth on the table. So right away I see that these two are twins of each other. They're both contact forces. They act on different objects. They act in opposite directions, and they're going to be equal. The size of the forces will be equal. Well, since this one's in the upward direction, well, look at this. The table will be in the downward direction, and that makes sense. The table will be pushing down on Earth. Downward direction. Okay. Well, the ball's not touching the Earth. There's no other contact forces we're going to worry about right now. Field forces. Okay. Well, check this out. I need to think about how the Earth affected the table through weight and how the Earth affected the ball through weight, because those two forces will have twins. Again, if I look at, reversing these two things, Earth on ball, well, there's going to be a twin where the ball is affecting Earth. Here, Earth on table, there's going to be its twin, table affecting Earth. Alright, so those two forces must exist. There's a force, I'm going to reverse this guy, the table, acting on Earth. And those are the reverse of this. I have those guys as twins. There will also be force of the ball acting on Earth. And since those are the reverse of this guy, then what I have is those are twins of each other. Well, look at this. There's another force here that I haven't found a twin for, another force here I haven't found a twin for. This is force of table on ball in the upward direction. This is force of ball on table in the downward direction. Yep, those are twins of each other. Absolutely. So that's just identifying forces that are acting on different objects. It turns out that just about all the time we are probably going to be able to ignore this. Any forces that are actually affecting Earth, we are probably going to be able to ignore. And the reason is simple. Earth is so huge, its mass is so large, that any acceleration that Earth will experience because of these various forces will be so small that we will never notice them. Unless we're talking about larger forces, the forces that might keep Earth in orbit around the sun, but we're not there. We're not there. Okay. So yes, the ball on the table do affect Earth, but we're going to ignore those effects because they are so small. So I hope that helps. I'm going to create a different video in just a minute. You want to look for this one as well. It's going to show the mathematical side of things, where we look at the sum of forces. So thanks for watching, and I will see you soon.